set-valued Markov chain dependability model with uncertain criteria.
Thank you very much. Dear colleagues,
Wait a
one
moment
moment.
before you
Yeah.
start. We need to
1 second. Please wait 1 second because it's necessary to check the availability of all presenters today.
So also,
Okay. Do you see my presentation, dear colleagues?
Leonid Mikhailovich, 1 minute, please. We will check all presenters. After that,
Okay.
welcome for you. 1 minute, sorry.
Okay.
if you can
Okay.
stop sharing, so we'll see the schedule again. Can you stop sharing?
Stop sharing
One
for 1
moment.
minute
For 1
to
minute.
check
Yes.
participants. Thank you.
Okay. So resume. Okay. So from presentation 6653, is someone here? The vertical horizontal model of states.
Yes, yes, I'm
Okay,
here.
thank you. Presentation 7142, machine learning based failure rate identification. Someone here to present?
Yes, of course, I'm here. Thank you.
Thank you. And presentation 7274. The swarm of unmanned aerial vehicles as a multi-state queuing system.
Dr. Klushnikov here, yes?
Oh, I'm here. I'm ready.
Thank you.
Okay. And presentation 8874 for the data dissemination planning tasks process model into account the entities differently.
I'm here. Good
Okay.
day.
And finally, 9733, modeling safety of connected autonomous vehicles.
Yes, I'm here.
Okay, so we are ready to start. So I will stop sharing. And if the presenter from 6415 is ready, please start.
Yes, thank you. Okay, dear colleagues, do you see my presentation? Is this okay?
Yes.
Yes, maybe if you want to present the maximized screen, it would be a little bit better.
Okay. Yes. Dear colleagues, my name is Leonid Lyubchik. I am a professor of National Technical University Kharkov Polytechnical Institute, Department of Computer Mathematics and Data Analysis. In our department, we have a scientific team which work in the field of mathematical modeling and machine learning with application to large-scale system analysis and design, particularly in the field of application of this method to the dependability and reliability analysis. So we present two papers devoted exactly to some topics from the mathematical models and other to the machine learning. The first our paper is safe-valued Markov chain dependability model with uncertain data. The brief content, we will discuss the very important, very interesting problem of theoretical foundation of the analysis of reliability system, well-known methods. It is Markov chain model, but in last years, great attention was devoted to the development of these methods, to the situation of uncertain initial data. Then the parameters of the models is not exactly known, and we should apply some methods of uncertain analysis. For example, it's called set-valued Markov chain and another, and we will consider the new approach to interval estimation of Markov model. Exactly, it is a method which interval estimation via optimization approach. It gives us the possibility to obtain some results with lead to effective analysis with large scale model. And first of all, it is well known that the dependability analysis consists for construction, solution, and suitable models. There are a lot of models maybe applied to this problem. Most important from this, it is maybe stochastic patterns and Markov chain model. Markov chain model is maybe most popular, most effective approach to the modeling of different situation is dependability reliability analysis. But in real problems, transition matters of dependability Markov models as a rule is not exactly known, since these matrices are estimated from the results of experiments. So when we find some approach which is suitable to consideration of real system, it is necessary to take into account that the parameters of our model don't exactly known, and we should apply some methods of the asserted analysis. It may be interval analysis, maybe probability analysis, maybe another, but from the practical point of view, it is more suitable the called interval analysis, which based on the set value description of the uncertainty of such objects. We will consider this problem and effective methods for self-valued Markov chains analysis and set description of uncertainties give us the possibility to find the bound characteristic of transcendent steady-state probabilities of Markov process. And interval analysis approach is also may be extended to most complicated situation. It may be in homogeneous Markov chain with variant parameters. Interval Markov change that provide us to obtain the upper and lower bounds of probabilities, and this cover all possible scenarios for evolution of state probabilities. One of the most important main interesting problem associated with the application of interval analysis methods to uncertain Markov chains, this connected with the computational complexity, because interval mathematics from the computational point of view, it is a very difficult mathematical approach, because it is connected with some transformation of geometric objects, of multidimensional geometric objects. It's connected with a different complicated methods of the calculation of such estimates. So the main idea of our work is to obtain the most effective methods which connected with another idea of the obtained of lower upper bounds of probabilities which are the consideration. It is optimization approach. We proposed a new approach to interval estimation for Markov models with uncertain parameters, which based on optimization technique to obtain boundary estimates of both transition and station probabilities. Main idea of this approach, it is a transition from the description of uncertain transition matrices using a set of polyhedral multidimensional space to the description using a family of approximated ellipsoids. Using ellipsoids and the description of a certain structure of initial data give us the possibility to obtain very effective computational procedure which gives us the estimates of probabilities of the state of the system as a result of not very difficult solution from the special optimization with linear functional and quadratic constraints. The developed techniques made it possible to significantly simplify the numerical procedure of upper and lower bounds estimate of transitions and steady-state probabilities and unify consideration of various uncertainty models. So, main results of our work, it is from our point of view, it's some general technique of self-valid Markov chain models analysis based on ellipsoid approximation. We solved two problems. First, it is interval estimate of steady-state probability vector of continuous time Markov change, and another problem, it is interval estimate of transient state probability of embedded Markov chain in discrete time. Some theoretical background is well known. It is a typical description of Markov models, which consists from the transition behavior called Markov differential equations. It is well known that the steady state probabilities may be found as a solution on linear equations. It is equation with connected with the generator matrix of continuous time Markov change, but in our situation, we consider the problem of find of solution of this equation from the steady state probability, taking into account the special restriction to the unknown genetic matrix. For example, it may be restriction as the linear inequalities for all elements of this matrix. It is not very difficult to obtain the upper and lower bounds of all elements of the generated matrix from the initial data, for example, for file race and another characteristics of real problem. And using this description, they consider another problem. It is a problem of set valued embellished discrete time Markov chain. It is the typical model which describe this situation, but we added the uncertainty set which describes the uncertainty in the transition matrix elements. So about the problems. It is first problem. It is the interval estimate of steady state probability vector of set value Markov change. It is necessary to find an interval estimate using the so-called polyhedron descriptions of the uncertain parameters, and we will find these characteristics of uncertainty as the maximum minimum components of normalized solution on literal linear algebraic equations. And another problem, it is interval estimate of transition state probability vector. Such the problem connected with obtain the recurrent equations, which give us the possibility to step by step calculate the constraints and the upper bounds of the probability vectors using the well-known dynamic equation of matrix chain. Some words about the solution on this problem. First problem, we find the characteristics of uncertain set which describe the solution of steady state Markov model or steady state solution Markov model as an optimization problem. Find the optimization of linear functional, this additional constraints which describe our uncertain characteristics. But from mathematical point of view, it is one problem. It is linear optimization problem, linear programming. But in the situation where they have high dimension, the solution of this problem, of course, very difficult. But it is there are another difficulties. The solution of linear programming problem is very sensitive to changing of initial data. And in another situation, it is necessary to obtain the solution that have some characteristics with low sensitivity, because it is necessary to take into account that all of our initial data has errors. It is as a result, we propose the transition from the linear programming problem to the linear quadratic programming problem using the ellipsoid approximation of the characteristics of our uncertainty. In such a case, using standard methods of the solution optimization problem, we use Lagrange function approach. It is very easy to obtain, in fact, analytical solution of this problem is described in this slide, but Lagrange multipliers will be found as a solution of nonlinear algebraic equations, and the result we obtain the estimation with the help of very simple computational procedure. Another steps, it is obtained the characteristics of transient behavior of probability interval vectors, and in such a case, we using the ellipsoid approximation, we give the step-by-step algorithms, we give us the possibility to obtain ellipsoid approximation as a recurrent equations in the probability state space. a solution was obtained using constraint optimization Lagrange function 2, and this describe the results as a recurrent procedure to obtain this characteristics. And a little example is very simple, but it demonstrates the possibility to apply this approach to the real problem. Of course, in the field of large dimensions, computational methods with such proposed approach, but in this simple simple example, it is very easy to see the effective results of this approach. We consider the model taken with these papers. It is a benchmark model with very fast use in order to illustrate some methods. It is very simple object, only 4 states. These characteristics of these states of our system transition describes the transition from one state to another. Some parameters were taken of the paper which I mentioned here, and the results. Using our approach, this is a model transition graph and generated matrix which used in order to illustrate the computation method. And these results of computations. It is a system availability, the probability to state 1 normal function with connected with the parameters of our system, and this is demonstrates the possibility to apply our upper and lower bound of probabilities. We consider the for the is a computation, we consider situation that the uncertainty is equal for all elements of transition matrix, but in the general situation, it very easy to obtain such the diagrams for any type of uncertain characteristics of our system. And thank you for your attention. Thank you. Your question, please.
Okay, thank you very much for your presentation. And now we have time for questions. I have one question, if it's possible.
So of course. Of course.
6 months ago, we tried to use interval mathematics for Markov model-based analysis, but we got some problems related to logical interpretation of result, assessment of final probability of states regarding to intervals of initial parameters, similar failure rate, recovery rates, and so on. You suggested a method of optimization, and my question is 2 questions. First one, what about the guarantee of logistic corresponding changing of initial parameters and final probabilities? And second one, if you can say about what is the difference between optimal and non-optimal rational decision according to your methods. Thank you.
No, thank you. First question about the dependence. Of course, when we use any methods of taking into account uncertainty in the describing of the solution of Markov model, it is necessary to investigate the dependence between the uncertainty of initial data and the final the results of the steady state, for example, probabilities. But Of course, it may be done only by numerical experiments, because, of course, it is not possible to obtain the analytical dependence from the characteristics of uncertain probabilities and uncertain parameters. Of course, any approaches, any methods, from my point of view, which may be used in such a field, must take into account the possibility of analysis of sensitivity of the results from the initial data. And the second question
Concerning optimization.
Optimization. Да. What about optimization? In our approach, optimization, it is only the instrument to obtain the solutions, because when we use interval mathematics as the basic instrument to obtain the results, it connected the some geometrical transformation in multidimensional field space. It is from the computational point of view very difficult, but not only from the computational. The assessment of the dependence in such a way is very difficult. And when we use optimization approach, we give the very simple path of obtain the solutions. And another, of course, verification, validation, this model, another take us the possibility of analysis of sensitivity dependence in such a way too. Thank you.
Thank you. Any other questions, colleagues? I don't see any questions. Okay. Hans says thank you very much.
Thank you again.
Yeah. Thank you. Thank you. And okay, dear colleagues, let's go ahead. And our next presentation, 6653, Alexander Gordeev and Daria Gordeeva. Please share your screen.
Okay. Yes, and oh, okay. Can you see my screen?
Yes, we hear you.
Yes.
Well, please.
Okay, thank you very much. Good afternoon. My name is Daria Gordeeva. I present to your attention a report on the topic vertical horizontal model of states of software with injected defects. First of all, I want to say a few words about the concept of injection of software defects. This is not a new concept, but well known. It is used to assess the quality of fault tolerance mechanisms and the quality of testing. Defects are injected into the software in accordance with the profile, and then the software with injected defects is tested. After that, the obtained results are analyzed and type of profiles are formed. Analysis of profile residuals allows you to make a decision in terms of increasing the level of fault tolerance or improving the quality of testing. Existing works devoted to an approach based on an injection of software defects can be logically divided into several following groups. The first group is works that are devoted to tools which describe their functionality and advantages. The second group of works is devoted to features of the applications of the software defects injection and its optimization. And the third group is works that are devoted to general approaches and concept of defect injection. And the fourth group is works that consider modeling the process of software defect injection at various development stages, including partially Markov models. It should be noted that there are no works in the field of software defect injection describing behavior of software with injected defects, included the number of injected defects and the variable number of active states. In this regard, the goal of this research is to describe states and transitions between them using Markov chain. On this slide, we introduce the basic concepts and types of software defects profiles. A profile of software defects, it's an ordered set of faults or defects consisting of taxonomy of a profile of software defects and specific defects that correspond to it. Misalignment of the profile of software defects is the inconsistency between types of defects profile in part of specific software defects. For example, between the profile of injected software defects and profile of discovered software defects. Forecasted defects profile is a profile of defects which represents the correspondence between the predicted taxonomy of software defects type and the real defects, the number of which corresponds to the predicted number of software defects. Injected defects profile, this is profile of defects, which is a subset of the forecasted defects profile. Real defects included in this profile are injected in the software. Profile of all discovered defects, this is profile of defects that were detected during software testing. Profile of newly discovered defects is profile of defects that were detected during testing and were not injected. Profile of discovered and injected defects. This is profile of defects that were detected during testing and were previously injected. And profile of not discovered and injected defects. This is defects that were previously injected but were not detected during testing. On this slide, we show formalized representation of software defects profile and variants of misalignments. Yes. Next, we will present and describe such misalignments in more detail. Combination of EPD profile and PADD profile, EPD profile, IPD, this injected defects profile and profile of all discovered defects represent all misalignments of profile of defects. The forecasted defects profile is required to present injected defects profile. All other options of profiles are a result of combination of injected profile defects and profile of all discovered defects. We will present the possible variants of misalignments of profiles in a formalized form. This is 10 variants of misalignments. Next, we will present and describe the model of software states with injected defects using Markov chain. The Markov chain is the like previous reporter said, in this case is presented as a sequence of transitions of software from state to state which are incompatible. Therefore, the considered Markov chain contains 4 states. First state is ideal software. Second state is software with injected defects. Third state is software with own defects. And fourth state is software with both own and injected defects. Next, we will present the topology of the directed graph in the form of an adjacency matrix. Therefore, taking into account the adjacency matrix, the matrix of transition probabilities is written in the following forms. The Markov chain at any stage k can be characterized by a column vector that is column vector by the distribution of probabilities over the states chain at the state k in the general form, and therefore this column vector of probabilities distribution on the initial states looks like here. And if P is the current probability distribution, then the distribution can be determined in the next step by the multiplying the vector by the transition matrix. From the associativity of matrix product, it follows that in order to find out the distribution of probabilities through the M steps started from case step, it is necessary to multiply this matrix to this vector. As already defined, the model of software states with injected defects generally consists of 4 states, and more detailed analysis of this model made it possible to clarify it and formulate the following statements. Each model has an additional attribute. This is software defects injection level, DIL. The injection level of software defects reflects the number of injected defects in the software. This attribute affects the model, including the number of active and inactive states of the model. Note that additional L index was introduced to indicate the vertical of directed graph. When this index equals 0 before defects are injected in the software, the active states include the state of ideal software and the state of software with own defects. And the state with injected defects and injected and own defects are inactive. When this index bigger than 0 after the injection of software defects, the state with injected defects and the state with injected and own defects are active, but the state of ideal software and the state with own defects are inactive. Each active state indicated by a solid line, in addition to the ideal state of software, can be detailed into several following states. This is normal state, false state, and failure state. We will present and describe the graph of transition at DIL index equals 0. This figure shows the transformation of the graph of physical state into the graph with transition probabilities. Active states are indicated by a solid line and inactive states by a dotted line. The topology of the directed graph in the form of adjacency matrix is presented in this table. Taking into account the adjacency matrix, the matrix of transition probabilities is written in the following form, and our vector of probability distribution for the initial state will have the following form. So a result, we will get a distribution of probabilities through the M steps, starting from the case step. And on this slide, we present and describe the transition graph for index DIL equals 1. This figure shows the transformation of the graph of physical states into the graph with transition probabilities. Equal states are indicated by a solid line, and inactive state indicated by a dotted line. If we take into account the adjacency matrix, the matrix of transition probability is written in the following form, and use vector of probability distribution, we receive as result distribution of probabilities through M steps started from the case step. As conclusion, as a result of this work, carry out a model of states of software with injected defects and transition between them using Markov chain was presented. In this case, the number of injected defects which affected the set of active and inactive states was taken into account. The result obtained made it possible to determine the distribution of transition probabilities between the designed states. And in the future, it is advisable to apply this result in the development of tools for injecting software defects or modeling real case of injecting. Thank you very much for your attention. If you have a question,
thank you very much.
ask me.
Thank you very much, Daria, for your presentation, for your very interesting talk. And now we have time for a question. Please.
If I can ask one question. Thank you, a very interesting presentation. I am familiar with software, but unfortunately not familiar with this concept that you presented of injecting defects or detecting defects. So first of all, could you give a Pullman's explanation to how you inject defects into software? So what kind of defects are they and how are they injected? A quick.
Okay, we can use different type of defects, and we construct a profile of injected defects, and we can inject these defects in software manually or using different tools for automated injection.
So you mean defects like being wrong in doing one mathematical operation, let's say, or is it something completely different, a different kind of defect?
We can construct this profile of defects, and we can use different type of defects. For example, this is wrong in calculation, or it's logical logical problem, or if no, for example, if you sign plus, but you need to sign minus, for example. So we construct this profile including different type of defects depending on what we use.
And so presumably when a program is very small, you kind of, if you say, for example, it's so small that you can see it on one screen, you can fix all the defects in it, and there are no defects. But as it grows very, very large and it's difficult to test, the defects appear when you don't expect them to. And so this kind of analysis, I understand, becomes very important. So what is the size of software that this analysis is useful for? Where is the turning point, the change? How many, I don't know, lines of code, functions should a program have to be useful or to have a meaning to do this kind of analysis?
And so this question is related to a problem of complexity software and complexity of your model.
First of all, is my assumption, the initial assumption, correct that if you have a 10-line program or a 20-line program, there is no point in doing this kind of analysis? Is that correct, according to your experience?
No, if I understand correctly a question, but this method is software injection defects. It's very popular method, and it use today it use a lot. So it's not only for simple program. Usually developer use this method for complex program too.
Yes. So this is my question, the actual question. From what point, what is the crossing point from a simple program to a complex program so that this kind of analysis is meaningful?
Maybe I think maybe I don't understand correctly the question. Sorry.
Maybe Alex can add.
Yes. Yes, Vyacheslav.
Okay.
Yes, thank you. I can answer this question because this work represent state of distribution between the state only with use Markov chains. Your question connect with volume of software. It field or this problem is not connected in this work, but is a very important question, and we can depends of our model from size, for example, size of software, number of string in the future.
So, and just to finish this, for training the Markov chain properly, how many fault defects should there be so that you can say that it has conversion, it has some meaningful probabilities that are...
Is a question related to parameterization of model.
Yes.
What about the number of faults which will be injected into code? It's just a question concerning parameters. From Dr. Nikos Doukas.
We describe only two states. The states of software without injection fault defects. Sorry. And next situation with injection only two position between without any parameterization.
Okay, hence in your case you suggested more general models and to take into account questions of Nikos. We need detailized assumption and initial points of the model, including, for example, is the difference between different injected defects. I mean, in point of view severity. And so this is, as we understood, it is the initial model which can be developed, improved, enhanced, considering more detailed parameters and description of assumption.
Yeah. Okay, thank you very much.
Thank you.
Can I ask a question?
Please.
It's Alexander Lubimov from National Aerospace University. Thank you for the great presentation, Alex and Daria. My question is related to how do you see if all these injections are made in the runtime? How do you see for the real-time software applications? How do you see the impact on the overall software execution cyclogram? How to tackle this problem when you inject errors, and then by injecting you kind of overload the software in runtime, so it behaves differently from its initial kind of cyclogram and timing.
Okay, Alex, thank you for your question. This question connected with technique for injection, software injection defect. But this this is a very known problem. What prefer injected defect in real-time program or software code? It depends on situation because we have connected with what goals we can receive.
I can add if you would like concerning question of Alexander Lubimov. This model not work in operation mode. It's a model for testing mode. I am correct, Alexander, Daria?
Yes.
Yes. Hence, you, Alexander, asked about about injection procedure in context of operation modes. In this case, this model works just in testing mode, and describe using Markov model process of testing using fault injection testing.
Yes, Vysosrich, it depends on goals. For example, if we want to testing procedure testing in company, yes, fault tolerant mechanism in software. It depends on goals.
Okay, so understand. It's not the runtime.
Yes. Okay. I think yes.
Thank you.
Thank you. Any other questions? No. Hence, thank you once more for presentation and for question and answers. And let's go ahead. We invite for the next presentation one more team of Professor Leonid Lyubchik, paper 71.42. Machine learning-based failure rate identification for predictive maintenance in Industry 4.0. Please share your screen. Leonid Mikhailovich, please share your screen.
Yes. Do you see the presentation?
Yes, see
Yes.
and hear you.
Yes.
Welcome.
Yes, thank you very much. Dear colleagues, this presentation with the title Machine Learning-Based Failure Rate Identification for Predictive Maintenance in Industry 4.0, it is the example of application of some modern approach to the classical problems. We will consider well-known problem of the identification of failure rate in the large-scale systems with methods of so-called kernel-based machine learning. So we will consider the typical problem of failure rate regression model building and propose the idea of construction of the regression models of high dimensional with difficult connected with a complicated structure of the dependence from the failure rate from the initial parameters. The development and implementation of smart manufacturing based variety of real-time information collection equipment, such as sensors networks, provides the opportunity to significantly improve efficiency of quality control in order to prevent both production and economic losses. So the possibility of obtaining a large amount of information give us the possibility to construct the models of high accuracy very difficult from the point of view of the dimension. So we will propose the methods to the construction of the regressive models of the without necessary to find the basic structure of this model. Among the problems of production management, an important place is occupied for preventive maintenance, which is an effective tool for reducing costs associated with failures and interruptions. Predictive maintenance, of course, is a key factor for ensuring the reliable operation of information and control systems. And In preventive maintenance implementation, failure rate is widely used as an important metric for evaluating equipment reliability, whereas failure rate prediction is an effective way to maintain decision making. Greatest interest in the development of methods for predicting failure rate using their models, which take into account the influence of various technological and operational factors controlled during system operation. It is a classical problem. First work in the field of identification of failure rate was done about maybe 50 years ago from the classical works of Professor Mikhail Stabinetsky from Kharkov. He proposed the first approach to the regressive model building of the failure rate. Now this approach is implemented by middle multivariate regression model to estimate the relationship between effective factors predictors of covariance and failure rates. But a common approach to building regression models involves pre-selecting of model structure. It is the most important and most difficult problem because it is necessary to find a structure of this model in order to obtain first high accuracy of approximation, and the second take into account the restriction of our data and a priori information. In fact, typical approach to this problem, it is first parameterized functional relationship between the output variable and effective variables. It followed by statistical estimation of unknown model parameters. On model training, thus it may be statistical approach, for example, maximum likelihood, mean square errors, and so on. And the second one, model training, it is machine learning approach to this problem. The main problem lies in choice of model structure, the complexity of which should correspond to the amount of data available for trained model. In this paper, we propose the approach of kernel-rich regression machine learning, and the main steps of obtaining the model of failure rate, it is first data preprocessing aggregation. The second one, it is model training along the regularization and smoothing, and of course, model verification and validation. Problem statement. We will consider the typical statement of identification of the failure rate. So we have some structure of this model. We use the typical model as a parameterized quasi-linear model, which may be represented as a dot product for the vector of the coordinate functions and vector of unknown parameters. So, step is the find of coordinate function. For example, it may be polynomial function and so on. And the second step, it is the estimation of unknown parameters. It is classical approach. In matrix vector form, we have the measurement equation. And the second step, of course, it is the estimation of unknown parameters. Classical approach, for example, using ordinal least squares, and we obtained the results as the optimization of the quadratic functional, and the well-known results as the estimation of known parameters. But the main problem is, first, it is a rational choice of coordinate functions, because if the dependence of the output function of the dependence of the failure rate from the affected factors is very complicated, and we have no a priori information in order to describe this dependence. The choice of the coordinate function is very difficult. For example, when they use typical classical approach, for example, polynomial regression, it is a problem to find degree of polynomials which are used in this field. And this problem is very difficult because it is necessary to obtain solution in the two steps. First, estimated of the unknown parameters, and another step, it is a find of construction regression which most suitable to our data. When they use the approach connected to the machine learning, they may propose the idea of use kernel models in such a way it is not necessary to construct the polynomial structure, for example, of regression, and the structure of failure rate regression models will be the following. Excuse me. First, we proposed two choice of coordinate functions, so it with dot products with the kernel function. It is a classical approach. We describe in a lot of work in the field of machine learning and demonstrate very efficient in the situation. Then we have no a priori information about what function we want to identify. We use the radial basis function, kernel function. That is, of course, typical structure of kernel models. And the results, they obtained the regularization functional in order to find the parameters of the kernel models. The solution of this optimization problem is demonstrated here using the classical approach, of course, Lagrange function with rich term width ensures the possibility of regularization of such a problem. We find the estimation of known parameters in the as a structure of rich regression call models. It is very important that the results of estimate doesn't include the coordinate function. So we only construct model as a linear combination of the kernel functions in the point which we include in our trained data set. So in such a way, we obtained another problem. The number of kernels which used to determine the number of points attained data set, this result in have the property of spatial oscillations. So from it is necessary to take a large amount of kernel function in order to obtain high accuracy, and from another point of view, it is not necessary to take a very large amount because they have the very properties of so-called spatial oscillation of our result function. To do this, we use the additional regularization using data graph models. Describe some adjacent graph consists of nodes which all observe data points wherein the age connected to nodes is weighted by kernel function, which reflects data cloud geometric structure. This is an example of such type of regularization of our problem, which use another regularization term which describes the structure of initial data cloud. And as a result, they obtained the smoothing kernel regression model. This data-dependent kernel corresponded to the so-called semi-norm of our regularization term. This is a result of solution. It's very simple. In order to obtain the results of the regression model in such a case, it's necessary only to solve a linear algebraic equations with only kernel matrix as a basic matrix of these equations. From the computation point of view, it is very easy to obtain the solutions, and as results, we obtain the structure of our model. Example, we illustrate this approach with a computational experiment with case study. This is a data from real semiconductor manufacturing industry. This data set is provided for experiments in machine learning for these applications. And this is the data set which we use. Data set contains data collected during the semiconductor manufacturing process and represent a series of monitoring signals from sensors and process manufacturing points. This is a preliminary analysis of data. Yes, first of all, data set consists from 1,500 examples, each with 300 measured features. So the dimensional model may be very large, only 100 of examples represents furrows. So it is necessary at first to do some preliminary analysis of data and pre-processing data cleaning. It is typical step in machine learning approach. It is the illustration of histogram of first 9 sensors. It is a covariance matrix heat map which demonstrates very complicated structure of data. So we, at first step of data cleaning, we consider the situation that pairs of features with a large covariance was removed from our data set, and after this manipulation we got a total that only 200 features. Another step it is data preprocessing, the aggregation of features, in which step the entire set observation was divided into successive intervals, for each of which observed number of errors was fixed, and the feature vector was replaced by the current average value of the intervals. In the second stage, the reduction of the number of features was performed by method factor analysis, and last, at first stage, clustering of reduced data set in factor space was carried out. After that steps, After these steps, we obtained the results of factor analysis of our features. We obtained only 5 factors. It is demonstrates that the hidden factors covariance matrix demonstrates the high quality of previous factor analysis. So we construct our model only from the 5 hidden factors. After that, we do the clusterization of this data in the factor space in order to obtain the smooth model of the flow rate. Clustering factor space was carried out in order to reduce the number of kernel function in resultant flow rate model, while center of clusters were chosen as center of the kernel components, and the average values of number of errors of each clusters were used as measures response function. And after that, they demonstrate the results. It is estimated regression model of the flow rate. It is, of course, only projections of the sum axis on the first, second, and other factors. It is the base kernel models and the smooth kernel models. Mean average error estimated from the not, of course, not from the training data set, but from the test data set, demonstrates the smooth kernel models has acquired quality and may be applied in order to construct these models. And the brief conclusion, obtained results indicate that flow rate kernel model regression model built using machine learning technique provides the opportunity to analyze influence of a large number of technological and both empirical effective factors and successful approximation of complex dependence of high accuracy. The results of computational experiments show that cluster-based smoother model demonstrates slight decrease in accuracy, but avoids spotty oscillations. It is very important from the point of view that obtained the realizable model, and as well as overfitting and more stable to outliers and noise. And further development of proposed approach may be connected with the developed methods and algorithms for flow rate and flow themselves forecasting based on combination of time series predictions method and proposed method of the identification of the flow rate function. Thank you very much for your attention.
Thank you so much for your presentation. Welcome, colleagues, for your questions. Short question.
Yes.
What about kind of equipment or any system in context Industry 4.0 or in context of predictive maintenance for 4.0? It is very important trend for this concept. Your opinion about type of such equipment where your approach would be very useful.
Yes, of course. We consider this idea only as a part of the main problem of the fall rate predictions. I think that it may be used as a combination of the different methods. Some method connected with the identification of fall rate, another methods it may be connected with the prediction, in time prediction, so forecasting of the measured signals from the equipment. We consider the real problems of the semiconductor process. In the data set was this data set was connected with the describing of type of sensor was used in this field, but from my point of view, it is necessary to use pre-filtering of this measured signals, and then combination of the identification may give the situation of the complex predictions may be considered as a part of the decision-making maintenance problem. I think that may be very important and very useful for the complex production system control.
Yes, thank you. It's really right. And
Thank you for
I maybe just suggest analyze tools which exist now for such kind of task. Maybe your approach could be embedded into or could be added to existing tools. It would be really very important for practical in practical issues. Thank you. Any other questions, colleagues?
Thank you for your.
No. Thank you very much, Professor Lyubchik, for your hard work during the presentation. Thank you. And let's go ahead. Our next presentation from National Aerospace University, as I see, Dr. Igor Klushnikov will present. Topic of presentation is swarm of UAVs as a multi-state client system with non-controlled and controlled degradation. Welcome. Igor, do you hear us? Yes. Igor, please share your screen.
All day long was okay, but
we understand
right now I realize what's something wrong with my internet connection. I
we
tried
see.
to share my screen.
Yeah.
Okay, please start.
Oh, thanks. My name is Igor Klushnikov. I am assistant of professor of Department Computer System Network and Cybersecurity of National Aerospace University, KAI. And dear organizer and participant of conference, report swarm of unmanned aerial vehicles as multi-state queen system with non-controlled and controlled degradations is presented for your attention. The agenda of presentation is follow. Introduction with motivation, state of the art, the aim of this works, and the objective of research. Main results were different models, two models of unmanned aerial vehicles, swarm-based multi-state queen system with non-controlled and controlled degradations are presented, and also case of study. And short conclusion with discussion and next steps for our research. The utilization of unmanned aerial vehicles for source and various requests allow to create a flexible system able For example, deploy different tasks of networks to create different monitoring system, for example, for future smart cities, and also different delivery services, for example, for medicine, goods, or food deliveries, such Amazon, Project Wings, DHLs, and different projects. But the UAV is a complex technical system, therefore, like all technical system, it can fail. And the failure of UAV while servicing a request can result in the loss of a request. But there are also a situation where the failure of individual unmanned aerial vehicles of the swarms does not lead to the termination of the mission. For example, if the mission of the swarms is to search for an object in a specified area within a specified time, the occurrence of unmanned aerial vehicles during the performing this mission does not lead to its termination, but will only increase the search time. And in this case, decrease the efficiency of these missions. Whose the unmanned aerial vehicles swarm-based sources with the approach of reliability of efficiency assessment of unmanned aerial vehicles are considered in many studies. In order to increase the amount of parcels delivery to customers safely, we study unmanned aerial vehicle delivery schedule optimization, considered the reliability on UAV, presents the concept of including the reliability issues in the drone delivery scheduling. The paper importance analysis into kinds of redundant system, K out of N, and consecutive K out of N systems suggest the possible use of the Birnbaum importance-based genetic algorithms to solve the reliability optimizations problem. Considering a UAV as a multi-state system invokes an unmanned aerial vehicles as the multi-state system, address the reliability models of UAV taking into account of the compositions of the UAV into degradable and non-degradable components. The paper Swarm of Public Unmanned Aerial Vehicles as Queen Networks consider UAVs utilized to build flying sensors networks as a Queen system and where swarms as Queen networks. But most of the considered works propose approaches of assessment of reliability unmanned aerial vehicles as UAV-based monitoring system, taking into account the fatal failures of unmanned aerial vehicles, but do not consider different strategies of state controls with UAV-based Queen system in case when we system system with multi-states. The aim of this work is to present model described various kinds of degradations, UAV swarm-based multi-state Queen system, non-controlled and controlled, as well as to study different strategies for distributing of unmanned aerial vehicles in swarm in case fault during servicing customers. The objectives of research are following: developing the model with non-controlled degradations, developing model with non-controlled degradation, and describing different strategies of UAV swarm-based queen system utilizations, and research of result of utilization different strategies of unmanned aerial vehicle swarm-based multi-state queen system in case study. The model of UAV swarm-based multi-state queen system with non-controlled degradation is presented with slide and with model of queen system which can describe by candle Lee notation, which shown in top of this slide. With model described queen system with poisoned process, inter-arrival rates lambda with its first letter M, also the service time with model Markov models of with queen system shown in figure 1, where 4 set in this model. First set comprise the state where all UAV are operable. The set of states 2 comprises the states where one or more UAV are non-operable, but in this case all request services but with lower services rate. Set of states 3 comprise the states where all UAV are not operable and the existing requests are lost. And the set of states 4 comprises the states where all unmanned aerial vehicles are involved in services where requests. This model is an example of queen system with non-controlled degradation, in which cases degradation is naturally, and we can't affect on this process.
Igor, do you hear us? Sorry, some problem with connection.
A different degree of importance, depending on where weighting coefficient. Assume what the sum of weighting coefficient is 1. In this case, when all unmanned aerial vehicles are involved in servicing, the request and can file the various strategies for servicing a request can be discovered. Strategies without reallocation unmanned aerial vehicles, first strategies, and second one, strategies with reallocation of resources. A strategy without the reallocation of resources in which case UAV, is utilized in case of failures of UAVs that a part of the swarm servicing the request with less weighting coefficient. In this case, coefficient G lower than coefficient G1. A strategy with the reallocation of resources is utilized in case of failure of unmanned aerial vehicles, what are parts of the swarm servicing the request with a large weighting coefficient. The reallocations of UAV in this case
because
can make
know that we have not lost the connection. It's not us. Sorry.
Igor,
It's strange, but from Ukraine, I'm continue hearing of the presenter.
okay, let's suggest Igor to more quickly go to finish because we have. Igor, please.
I understand I have a problem.
Yes, please more quickly go ahead because we worry about connection. Please.
Yes, I understand.
More quickly.
In this slide, present an example of model with different weighting coefficient customers rates, and when utilize two swarms of UAV, and in this case we can use UAV from swarms which source request with less weighting coefficient when it is necessary to solving requests with bigger weighting coefficient. But in this case can be situation when we don't know exactly in which states make it possible make transition, because we don't know how many UAVs in second swarms fault. With uncertainty in regard to transmission between states. And to cope with this problem, the following assumption that the swarm services the request which less weighting coefficient can allocate a UAV only when it's on all services. The case study present the easiest UAV service, UAV swarm-based queen system, which services two kind of customers. First one is customers where need to delivery medicine with branch, and second one the customers where we need to deliver food, second branch. And very simplest very simple model, and in this case where request to deliver medicine have large weighting coefficient when request to deliver food, and when all unmanned aerial vehicles used to serve all requests, and one of them file. In this case, we use unmanned aerial vehicles, which is which we can use, and In this model, we use 3 unmanned aerial vehicles, one to serve a request for medicine delivery, one to serve a request for food, and one is reserve. And when reserve unmanned aerial vehicles is also used, in this case, we use the unmanned aerial vehicles which serve request for food delivery, and in this case, this request lost. On this slide, present system of equations which make it possible to assessment stationary probability of being system if in with different states. And for initial data presented on the top of slide, we obtain follow result. If we use strategy with reallocation, when we don't use VAV from branch food delivery, total losses of request when total amount of requests for this system equal 10,000, total loss of medicine requests is equal 49, and for food delivery is equal 16. When we use strategy with reallocation resources, in this case, total loss of medicine delivery request is equal 22, and food delivery is equal 18. But in this case, the total losses in conventional units for different weighting coefficient. If we use strategies without reallocations, in this case, non-controlled degradations, total losses is equal 27 conventional units, and when we use strategy with reallocations, unmanned aerial vehicles, total losses equal 21 conventional units, with less than 24 persons. And conclusions. In our works, various Markov models of unmanned aerial vehicles swarm-based multi-state wind system are developed and explored. An example of model servicing the request for food and medicine delivery in futures of unmanned aerial vehicles, and when the using controlled and non-controlled degradation was given and analyzed. It was demonstrated what the forgiven data utilization of controlled degradation strategy with reallocation of resource provide decreasing the overall losses of request by 44 persons. It was found what the total numbers of lost requests when applying different strategies remains unchanged. And the next research steps can cover the deployment of models, unmanned aerial vehicles, swarm-based multi-state wind system, taking into account strategies of utilizing the ground components of WISC wind system. That's all.
Thank you
for your attention.
Thank you for your presentation. Sorry, we have not a lot of time for questions, but if you would like 1, 2 questions, please.
Alexander Lubimov is here. What was the method used to assess, the weighting coefficient of the particular swarm? How do you calculate the readiness of particular swarm to do the operation?
In this case, I use building method in Excel and found probability of binding states with matrix.
Can I add maybe? I think in this case we have not any problems with calculation of.
Yes.
Yes, but problem just maybe connected with complexity of model. If in any case we can go ahead step by step. First stage is development of Markov graphs, considering quiet theory, and next one matrix, and next one simulation results. And so, as I understand, the main problems here can be related to complexity of system. Yes, because if you talk about UAV fleets, which consist of 10 or more UAVs, in this case we have more complex graph, and combining different strategy. If you use different strategies of maintenance and application, problem of complexity will become more and more. Thank you.
Okay, thank you very much. I was just working a few times with not the swarms but mesh networks with radio nodes, and having a lot of redundant data exchanges between different nodes makes model super complex, especially with the radio communication, where you have black spot problems and continuous reconfiguration of swarms or mesh networks. It really gives some challenging problems, as I see it.
If we use more complex model, it is necessary to simulation with system, because in this case take place the size explosion and very difficult to make special to obtain question which describe this model.
Okay, thank you for very interesting question and very interesting comments. What about other questions? I don't see. Thank you one more, Igor Nikolaevich. Thank you all for. Thank you, Alexander, for your questions.
Thank you.
And let's continue our session. Sorry, we have not a lot of time, but we have two very interesting presentations. Next presentation, 8874, the data dissemination planning task process model into account the entities differentity. Sorry, who will present this paper?
Yes, hello. One moment, please. I use my presentation. Do you see?
Yes, we see, we hear, and we're glad to see you.
I'm glad to see you too. Dear colleagues, dear participant of the conference, I present to your attention a report on the topic the data dissemination planning task process model into account the entity's differentity. This report was made by the team of the authors. It is I, Serhiy Semenov, Serhiy Inhalychev, Vyacheslav Lamarenko. It is professional from Cybersecurity and Information Technologies Department of Simon Kuznets, Kharkiv National University of Economics, and Professor Svetlana Gavrilenko, the Computer Engineering and Programming Department of National Technical University, Kharkiv Polytechnic Institute. My report have some question. You can see this question on slide number 2. It is introduction, analysis of Ukraine and other modern scientific sources, generalized job scheduling model and entities with dependencies, mathematical model for scheduling data dissemination task. The result of the study, these mathematical models in conclusions. If I speak about introduction, I can speak the information service range expansion in cloud environments, the increasing interest in network and computer resources on the part of modern society, as well as the growth in the number of their consumers causes and objective need to solve their problems in increasing the efficiency of using these resources. But a lot of IT company, IT organization use a lot of solve for different technologies. It is computer class, it's a grid system and cloud system, it's a lot of else. At the same time, the analysis of distributed data processing system, as well as protocols and algorithms for their functioning, show significant limitations that reduce the efficiency of information exchange and data processing process. These limitations are caused by the heterogeneity of the processing object, as well as the fuzziness of the input data about the entities. These factors impose additional restriction on the entity description model and require the improvement of existing task scheduler to handle them. One moment. The purpose of the study is to improve the data dissemination task scheduler model, taking into account the heterogeneity of entities. When modeling, it is necessary to provide for the use of additional blocks for analyzing and adaptation entities to the existing capabilities of processor and other resources. The analysis of literature made it possible to present a block diagram of the flow of entities for planning system in the form of figure number 1 in this slide. In the a lot of article on this basic of the above figure, that concept of an entity was substantiated and visualized within enters the input of the planning system and consists of a set of tasks. As can be seen from this figure, task tree enters the input queue. At the same time, tasks are the minimum planning unit. Within a single entity, jobs can be classified into independent jobs and organized into a generalized structure called a dependency tree. Accordingly, such entities can be executed independently of each other or sequentially if there are dependencies. Dependencies defined on the order in which work is performed and the flow of data between entities. An analysis of some literature, a lot of literature showed that various service disciplines can be used in practice to plan tasks. At the same time, the conducted studies made it possible to single out those service disciplines that are supported by the expert environment as the main ones in solving the problems of planning and managing computer resources, while taking into account the need to process entities of a different structure. These are disciplines such as FIFO, LIFO, RSS, and else. The conducted studies have shown that despite the practical relevance of the service disciplines, they are not without a number of shortcomings associated with the assumption of the same time of task in terms of requirements for computing information and other resources, as well as the lack of flexibility in evaluation, job handlers, and entities. At the same time, underestimation of these shortcomings leads to a decrease in the efficiency of using computer resources in case of heterogeneity of task scheduler nodes, heterogeneity of the computational and spatial complexity of the task and entities themselves, the possibility of parallel data processing when scheduling tasks. The conducting resource showed that on the one hand, the above disadvantages of not taking into account the heterogeneity of job and entities can be eliminated by using such a service discipline as discipline short job first, where the task with the lowest resource requirements of the short remaining processing time discipline, where a task is selected for which the estimated service time is minimal. However, the need for a priority date on resource requirements significantly limits the possibilities for the practical use of those disciplines. Another important aspect of the considered task scheduling model is the storage of data on the status of task execution. This in many ways allows you to interrupt the execution of the current task and switch to the execution of another higher priority task. Such disciplines as time sharing, least attained service, short remaining processor time belong to this class of task scheduler models. Therefore, each computing model has the ability to process several entities at different stage of execution. Storing date on the state of task execution is widely used for scheduling processes in operation system when several processes are sequentially allocated a quantum of processor time to create pseudo-parallelism. However, this strategy introduced additional overhead and may not be suitable for interrupting computationally intensive tasks. Considering the next stage of planning, it can be noted that for each selected task, you can use node selection procedures, which determine the required amount of resources for data processing tasks. This allows you to build a planning process taking into account the state of each node, as well as in accordance with the preset application requirements. The disciplines of assigning nodes to tasks can also differ from each other depending on the available priority information. At first, it is less used node. Second, random selection. Estimate the remaining execution time. Prediction of resource consumption. A significant drawback of the above planning disciplines is the consideration of the task selected process and the not selected process as independent stage of planning. The initial selection of the highest priority task followed by the quasi-optimal selection of the node. Despite the fact that at each individual stage a quasi-optimal decision is made, in general, the process of distributing a set of tasks in a set of nodes is often far from optimal. To search for a quasi-optimal assignment of a group of tasks to a group of nodes, it is required to consider the indicated planning procedure within one stage. Schematically, the models and methods of task planning can be represented in the form of figure in slide number 5. It is a figure. Let's study the presented scheme using the mathematical formalization of the planning process for the dissemination problems. To do this, we use the methods of GERT network modeling. On next slide, you can see figure the GERT network of the process of scheduling distribution tasks for a separate set of date tape is tape. Sorry, the use of the Manson formulas made it possible to represent the equivalent wave function of the execution time of the studied task scheduling process in the form of an expression number 1, this slide number 6. Studies have shown that the main disadvantage of such a scheme is the inefficient or use of resources and not in the case of calling and processing heterogeneous data. This is due to the lack of the possibility of preliminary analysis of resources capabilities and nodes in order to fill the remaining parts of the processor capabilities of computer system for processing heterogeneous data. Based on the presented result of the analysis, it can be concluded that it is necessary to improve task scheduling model in distributed data processing system. First of all, this is caused by the objectively existing condition of heterogeneity of input data and entities. It is expanded to carry out this improvement by introducing into the scheme on slide number 7. This slide, on this slide, you can see additional block of preliminary analysis and adoption of heterogeneous entity, which will also perform the function of adapting the processing used in it for processing entities to the internal capabilities of computer resources. This should make it possible to reduce the time spent on performing applied data processing tests. To solve the problem, we transform in this scheme the task scheduler scheme, slide number 7. Based on proposed, next slide. Based on the proposed concept of using additional procedures for preliminary analysis and adoption of heterogeneous entities, the GERT model is transformed into a network structure in figure on slide number 8. At the same time, the equivalent W function of the execution time of the improved process of scheduling data dissemination task, taking into account the possibilities of analysis and adoption of heterogeneous entities can be represented as the expression number 1, this slide. The use of the proposed equivalent W function in the future will allow use to determine the analytical expression for calculating the time span in the implementation of an improved job and entity scheduling process. The conducted studies of the task scheduling process and entities made it possible to form the characteristics of the branches considered in the GERT model and the distribution parameter and presented them in table number 1, slide number 9. This table, you can see the model branch characteristics. In accordance with the characteristics of the branch of the GET network, the equivalent W function of scheduling time for task and entity considering heterogeneity can be represented as expression number 1, slide number 10. Let's find the probability distribution density of the scheduling time for dissemination task of a separate set of date type. In this case, we define the following parameters of the branch of the GERT network as initial date, who can see in slide number 11. And for this case, figure shows a graph on the probability density distribution of the scheduling time for propagation task of a separate set of date type. As can be seen from this graph, the maximum values of the probability distribution density of the scheduling task for the distribution of a separate set of date type under condition of heterogeneity of entities fall within the interval from 0.08 to 0.17 CR. And finished, I can see conclusion the report. Thus, a model of the process of planning the task of data dissemination has been developed, and distinctive feature of this model is taking into account the heterogeneity of entities by including additional block of their analysis and adaptation to the existing capabilities of processor and other resources. This made it possible to determine the main probability temporal characteristic of the process. Future research will reduce time cost and improve the efficiency of using existing resources of computer system. In addition, the improvement of models and methods for analyzing and adapting entities for existing capabilities and resources of computer system will make it possible to substantiate their practical applicability and improve a number of characteristics of the function of a computer system. Thank you for attention. I can hear your question.
Thank you very much for your presentation. And please, question, colleagues.
Alexander is here. Thank you for presentation, Sergey. I can see that the problem you try to solve is actually a problem of classical superscalar architecture of existing processors. How do you deal with non-coherent data for different processes you try to schedule?
Alexander, sorry, repeat it, please. I can. Second question. How do you?
how do you deal with non-coherent data
Okay,
in your
understand.
proposed model?
Okay. I can answer this question. We can use a lot of methods. I think in future use methods fuzzy GERT network. It will do a lot of plus because I can see some border with big data with data. I can use my knowledge about this border, about different with data. I can I can take into account this different with data in this model.
Okay. Any other questions? No. Thank you very much, Professor Simonov, for your presentation. And let's continue our session. Thank you very much.
Thank you, colleagues.
We have one very interesting presentation from team of Dr. Peter Popov. As I understand, it's a presentation number 9733. Modeling safety of connected and autonomous vehicles and the cyber attacks on perception and safety monitors. Authors of this paper are Kosari, Peter Popov, and Rajikumar Roy. Welcome.
Yes. Hello.
Yes, Arya. Please share your.
Let me see if this works. I think I'm just going to share everything. It's giving me a bit of a problem trying to share it specifically. Is it visible now?
Yes.
Oh, good.
Yes, completely okay. We'll start.
Okay, so in this, myself, Ari Kosari, I'm a PhD student, and I was working with my supervisor, Dr. Peter Popov, who presented earlier at the plenary, and Professor Rajkumar Roy, the safety of connected autonomous vehicles, specifically the safety monitors and perception, but this time not just when a hazard's happening, but also when it's an attack, to see how a cyber attack would now have implications on safety. We'll start with an introduction just to kind of introduce CAVs and all the safety, then a bit of state of the art, our research objectives, followed by the main part, which is actually our models, the introducing the software, the hazard model and its different components, followed by the attack model, what kind of parameters we've set for the experiments, the results we've got, and a bit of a discussion, and then look at our conclusions and any work we plan to do on future. So, recent increase in automated systems has kind of led to more of a hands-off approach by human beings, and one of these examples is the connected autonomous vehicle. The machine's going to have to do some of our job. It means more connectivity, more information is going to be needed. However, this does increase the attack surface, especially when you're linking to things like Wi-Fi and networks and having sensors, because now you can have attacks on your perception, attacks through the communications. As much of an issue if it was just a computer system, because we would just deal with the computer side, but now we've got something like a vehicle which is cyber physical, so the computer system could actually lead to something like a car crash. We're mostly going to focus on like the perception system, the hazards, and the safety model. So we're going to see the vehicle trying to deal with hazards and perceive them by a malicious user who could probably be doing it remotely. As we know that perception is a key part of autonomous vehicles, perception, we know that if this part fails or doesn't function properly, for example, it's delayed for some reason, or one of the key components, such as sensor breaks, we're going to have issues, especially if a hazard suddenly pops up. To look at the hazard perception model when it's under attack, because there's been safety, there's been security, but this overlap is where it gets really serious, because cyber physical systems are now a fairly new area. Let's go into some of the ideas behind CAVs. So, side part, working our way towards the inside of the vehicle, it starts with the communications. So we've got vehicles communicating with each other, to communicate, their intentions and other information they may have gained, because if they all have as much information as possible, decisions can be coordinated and safer. Vehicle to infrastructure, because if we have infrastructure from different areas communicate with one another and give information from vehicles, we can organize traffic across longer distances. Information then goes into the actual vehicles, such as sensors, as well as the communications, will then go into the embedded subsystems of the vehicle called the ECUs, connected via a line network, which is typically the controller area network, or CAN bus. Quite fast, doesn't really have much security, and you don't need to really upgrade or install anything. You connect them, they have a CAN transceiver, they will communicate immediately. Some of these ECUs are connected to sensors. Many sensors are usually vulnerable to things like spoofing, where you can kind of give information that misleads it, like convincing it that it's either further away, the obstacle, or closer, which essentially the sensor is completely blinded by your attacker. And one of the more recent papers we've read, I think a 2022 one that came out very recently, was one where you could essentially blind it in such a way where you don't blind it fully, but you essentially delete a pedestrian from the view of the vehicle, so it keeps going as if it's not even in front of it. Our research objectives, basically our aim is to assess the safety capability of CAVs, specifically in the perception. Under attack, how is our safety affected? For the sake of this experiment, that false hazards aren't happening. So if a hazard's happening, it's definitely real. So it's there, we've either seen it or we haven't seen it. And our results should give us an idea of, when we individually compromise different parts of the hazard perception system, what the effects are. Without any of the parameters that will be activated in an attack, as well as all of them, to kind of get an idea of when no attacks are happening, and how it works when you've successfully compromised the entire system. So now we'll go on to the SAN model. So this is stochastic activity networks, which allow us to essentially have a sort of state machine in time occurring at different rates. For example, you could have hazards occurring at a certain rate, the accidents happening at a certain rate. The attacker could be attacking every few hours. This in the Mobius software, which is from Illinois University. This software also allows for simulations such as Monte Carlo, or the use of a numeric solver, control not only the time period across which we simulate, but the degree of accuracy, so like how many decimal places we want our values to. We have a lot of parameters, and we plan to expand them in the future to more different cases. We found that the numeric solver was just much faster, as it generated the states in advance, and there was less of them. So all of our tests have been done using a numeric solver. Model of the vehicle, observing different safety implications for basically 7 experiments, the baseline, the worst case, and the main 5 parameters modeled separately that I will describe further ahead. So firstly, this is the hazard model just on its own. I think if people watching the plenary earlier with Peter, they saw a similar model, but this one has been modified because we're taking into account attacks. State would, for example, have different scales built into these timed activities. So it could be like 3 times more likely to cause a certain event to happen. First thing we would be ignore that branch that goes student C, OK to FH, because we are not accounting for false hazards. So that's not going to do anything in the case of what we've done for this research. At a time of 100 hours, going up to 9,100 hours. A lot of states here, as you can see, like the OK state, that's before we start going to hazard perception. Falsely perceived hazard, we're not considering. You can perceive a hazard correctly, or you can overlook it, which could then lead it to delay. And then it could either be perceived correctly at a later time, which could shorten the reaction time to deal with it, or in many of the cases, you just go to an accident because you haven't managed to deal with it in time or detect it. Essentially, these are the different states and timed activities, because things like the OK to hazard is having us, for example, have a hazard occur at a fixed rate, and then the probability of either detecting it correctly or overlooking it, at which point you could either just continue to overlook it or detect it later, which could again lead to an accident. Time is one of the more interesting ones, because this is where you've got the delay from the overlook. So you could either not see it and go straight to an accident, or you see it later and now maybe because you're closer than usual to the hazard when you've got to deal with it, it could still lead to an accident, or you could just manage to clear it on time. Or the third option is that a hazard actually goes away, or for example, a vehicle in the middle of the road and you think you're seeing that as a hazard, it clears it. This is the part that gets slightly different from just a hazard model. We've now linked it to a very generic attack model, where we assume an attacker is always ready, attacking periodically at a fixed rate and succeeding with some fixed rate. When it succeeds, it would be compromised, which is linked to the compromised state in our hazard model. Now that takes effect and starts to put into play parameters that we want to test, make overlooking a hazard be more likely. Periodically resets the attack, because otherwise our model would just be constantly compromised and we wouldn't really get to see much difference. So the attacker's ready, then they go into actually performing the attack, which they'll either succeed or fail. They could compromise the system and the attackers just reset every once in a while. Now we get into the actual experiment. So these are our parameters that we're looking at when the system is compromised, and we're putting them on one at a time. So firstly, the hazard scale is basically, if we have a value for hazard scale, and that's what happens when you don't detect the hazard. So the vehicle's going along, there's a hazard, it just doesn't detect it. Base scale, so you could still detect it, but much later. So if you detect it earlier on, the vehicle can deal with it faster. Scale, this is more how you actually deal with the hazard. So it's detected the hazard, to deal with it, make the correct maneuvers, brake, etc. H to CH, this was essentially when the hazard is overlooked and you've still got to correct it. So when you've just completely overlooked it, this means an attack that makes you just overlook a hazard. The late CH to accident scale is similar to accident scale, but now it's late. So dealing with a hazard that you've detected late. We had a series of fixed parameters that were for our timed activities. So these meant controlling like rates of accidents given that we had a correctly perceived hazard. Essentially meant that we were at false hazard. Just the rate of the hazard overall, just for the attack rates. And finally, we assumed that the RSS, so the safety system, was not perfect, because that would be an ideal assumption, which is less realistic. And as you can see, experiments 1 through 7, we started with none of these parameters active. So accident scale meant when the system is compromised at accident scale meant, like, for example, your rate at which you're failing to deal with something could become 10 times as much. We created these individually for 5 experiments and then activated all of them once, so we could compare them to both the best case baseline and our worst case. So we then plotted all of these together, and as you can see, just about everything except for accident scale is the same as baseline, meaning the effects are essentially negligible. So we tabulated them as well, which is in the paper as well, because the graph wasn't showing them well enough. And we see that essentially one of the key things when you're dealing with these parameters on their own, so an attack that's compromised just the delay scale on its own is negligible, whereas if you compromise the vehicle's ability to deal with the hazard, physically take action, you have a serious issue, as it seems to essentially reach 100% likelihood of an accident at around 3,100 hours. Case is going to always give you the worst result, ideally, in this case. So we determine the following from it. A baseline, this is basically just how good the vehicle safety is when it's not being attacked, how it's dealing with hazards. Likelihood of dealing with an accident, yeah, this on its own is a serious problem. So how it takes action, delaying hazards or failing to detect them or otherwise is negligible on its own, but looking at the worst case cause serious issues. It's like the worst safety implications possible. So we can see that whereas accident scale on its own has the most effect, we see that if worst cases combined, we should consider looking into combinations of attacks on different parts. So the attacker gets in and compromises different parts of the hazard perception and safety monitors of the vehicle. So our conclusion is that individually attacking parts of the vehicle has very little effect, and that therefore we need to consider looking at the combined attacks. So for example, what if you attacked delay scale and accident scale together? We kind of see the path of an attacker, which would give us an idea of where defenses should go. But additionally, false hazards, because we didn't consider them, we need to see if, like, an attack that makes the vehicle think there's a hazard when there isn't one could lead to actions that actually make the vehicle a hazard to other vehicles on the road as well. Based off those conclusions, we are going to do combined attacks to see, like, which combinations have the worst effect on vehicle safety, and then even perhaps introduce defense models, either to many components at once, some of them, just to see how it affects safety implications in the presence of attacks, as well as testing false hazards. But we'll do these one at a time and then combine them all. If there are any questions, I will attempt to answer them to the best of my ability at this point.
Thank you for your presentation. And dear participants, please, your questions.
Thank you for your presentation, Area. 2 points. First of all, I think there is a standard called CANFD that actually supports the security on the ECU level of messages, and that's actually the part of the intrinsic safety of the vehicles. How did you analyze that part? Do you refer to the intrinsic safety built into the different parts and pieces of the vehicle?
I think the model is quite very generic at this point. It hasn't modeled a specific CAN component or anything. It's more of just a model that's looking at how it's dealing with hazards in general. But if we were to model like the CAN, that would have to be like its own model looking at all the rates at which like information is communicated and stuff.
Okay, understand. The second question is, in my mind, I think that the general reliability and the hazards protection of vehicles is somewhat connected to the vehicle readiness in the broad terms to carry out its main business function, meaning driving. How do you see the standardization impact in that regard? Because apparently, if there is some sort of spoofing, then the vehicle can just stop and just not move. That's it.
Yeah, that is definitely a major concern, especially like a jamming attack. That's what I was saying. If it convinces it that there's something in front of it, then depending on the RSS policy, it's going to stop in the road. And if it suddenly has to do this, then it could get rear-ended by a car.
Okay, and what the solution could be is vehicle-to-vehicle communication, or how do you see that?
I think there would have to be a mixture of the good RSS policy, vehicle-to-vehicle, and just to be able to kind of tell when a sudden detection prior to not having seen anything happens, just to be able to tell.
Thank you very much.
Thank you. My very short question about, what about, you talk about combination attack, yes?
Yes.
As I know, there is a problem of blackout for automotive infrastructure. Company Cisco informed about such cases. Can your approach to describe such kind of attacks and domino effect for vehicle-to-vehicle systems? Thank you.
I think it depends. If you're talking about infrastructure blacking out, that depends if that's a fault or if like the infrastructure is being subject to a denial of service attack by like a rogue entity pretending to be vehicles communicating with their vehicle. That's pretty close range. So provided it's not impersonation, it should be good.
Okay, sorry, I did not hear last your sentence. Please repeat last your.
Oh, vehicle to vehicle. I know that's pretty short range, so they communicate when they're close to one another. So provided it's that an attack isn't happening, which to be fair, that could be worth investigating as well. There's the vehicle works well normally, its performance up compared to an attack, for example, like civil attacks where they're pretending to be multiple vehicles communicating to mislead another vehicle in terms of how it changes direction.
Okay, thank you. Any other questions? No, thank you very much, Ariel Kalsari, for your presentation. Thank you. And thank you very much, all participants, all reporters of our session. Thank you very much, moderators, Dr. Nikos Doukas. And today our program very successfully finished, and see and hear you tomorrow on the our morning plenary session. It will be two very interesting presentation from industry and from Italy Institute of System and Technology, Information Technologies. Any questions? No. Thank you very much one more. See you and hear you tomorrow. Thank you.
Thank you.